What's up, you guys? Welcome to another Tidal Gardens podcast. And with us, we have a special guest all the way from Germany. This is Alex from Abyzz.
Hello, everyone.
Now, if you've been on this channel at all, you know what a gigantic fan of his products I am.
Thank
Like, I
you.
cannot stop talking about how much I like his pumps. So I am super happy that you're finally able to come and actually visit the facility in person.
I'm super happy too. It's taken quite a while, but the right opportunity and adding 2 more days into our travel, and here we are. And I'm blown away by what you are doing here. It's
Thank you
really, really
so
cool.
much. It's it is one thing to see it on YouTube because we do try to share a lot of like what we do, but it really is different to see it in person. I mean, it just has a very different feel to physically be here.
Yes, absolutely. And I couldn't believe, like, first thing that come. I mean, other than the visual impression you have in the beginning, is already you walk in and you're like, this is totally different than every other installation I've been in. I've been to quite a few, wholesalers, importers, huge companies, coral farms as well. And usually there's like a bunch of people running around, which right now it's Sunday, so that's probably part of why it's so silent. But it's remarkably clean and dead silent. Like that was the first thing that actually walk in and it's like, all right, it is actually as in your videos. And I always thought like, yeah, I mean, in the video you can always like turn down the noise level, everything, and fake it a little bit. But as you said, when you were visiting us, at Vivarium conference, um, yeah, I had to see it for myself. So I'm really, really happy and glad we could make it.
It's almost like a parlor trick of sorts that we like to do now because it's like a signature aspect of this coral farm.
Oh yeah.
And sometimes it's like it's so ridiculously quiet that it's like it's comical that it is a coral farm at all because it's not really supposed to be a quiet place. These are loud places typically.
Normally, yeah, but yours is not. I can like prove that it's definitely
And
different.
what contributes to that silence is also the use of a lot of your pumps.
Yeah, yeah,
And I would say that of all the pumps that we've ever used, the Abyzz is practically dead silent. There's only one application that we use it for where it does make a little bit of noise, but it is impossible to make that quiet because it's literally mixing air and water for a
yeah,
protein skimmer.
yeah,
That's going to make noise.
yeah. I mean, we could, technically probably make the pump housing another inch thicker, and then that would be more silent. But still, you have plumbing that where the gas mix or the water air mix goes through, so that will create noise. But I mean, noise as in it will make a sound. I wouldn't call that
Nobody would
noise.
think that skimmer is noisy because there's plenty of tiny skimmers that make more noise
Oh yeah,
than these gigantic MRC Pro
yeah,
4s,
yeah.
right?
Really good. And I've just been meeting Raj this whole past week for the conference that we're at, and he told me like, "Oh, you're going to see some nice MRC skimmers," and I'm like, "Yeah, I know your skimmers, right?" And I knew that you exchanged the pumps on them for that very reason that you wanted it like, yeah. I mean, you're definitely pushing things to the max on everything. We're just discussing your equipment here, and I'm like, whoa, all right, this is like a professional recording studio. So yeah, I'm really really amazed, and I love the setup. When it comes to the skimmers, I never saw the that size of the skimmer model actually running with our needle wheels. So that was impressive and interesting injector, which I don't have. So we do have a needle wheel kit for the pumps. But since I'm not a skimmer manufacturer, it's hard for me to build something ready to go to basically match every skimmer out there. So it
Hmm.
takes always the effort of the skimmer manufacturer as well, if they want to do that with our pumps, to match the just the design of the pump head and everything and the injector to their skimmer. So I think these are really well fitted.
Yeah, and I think that it's also it's so uncommon. It's such a niche application that there's not going to be a lot of examples out there. And that was one of the reasons why I really wanted to make that video, because there's ones of people out there that are interested in this thing, and they will find literally zero information about this anywhere else.
No, absolutely, yeah.
And it was actually kind of funny because like shortly after publishing that video, one of these very high end tank installers, they were like thanking me because of that particular video, because they have a client that is interested in an Abyzz modified MRC skimmer,
Yeah. Yeah.
and it's
And
the
here we go.
only. And so he was just like, we throw around the word influencer a lot, but you are literally influencing us to make this purchase on behalf of a client. So thank you for that.
Yeah, no, that definitely helps, especially if you have those niche applications where, not everyone would think of that. I mean, we all know that is an investment if you use our products, but in most regions, they do pay off eventually. So you have a return of invest, and
It
the
doubled the price of the skimmer.
yeah. Well, okay, yeah. So it's not cheap. This come on.
The skimmer was not cheap. The
No,
pump was not
yeah,
cheap.
I know. But you see what you get. I mean, you have a very good performing skimmer in a size that is, like a smaller commercial model. That you see this size also in public aquariums. Quite a few. I mean, it's not only those walk-in size skimmers in public aquariums where I go a lot, and I've seen many behind the scenes, and there's like in the average aquarium you might have like 2 or 3 or maybe 5 giant skimmers, but then there will also be behind the scenes in all those breeding tanks or quarantine areas, you'll find hundreds of smaller skimmers that are sourced from the hobbyist side of things. And some facilities now, especially when they're doing renovations or being built new, they are actually making sure that they have something that is more silent and more efficient as energy prices are rising around the world. I mean, you are still in a pretty good spot on that.
We're in an amazing spot right now
Yeah.
because I would say that in the past several years, we have enjoyed 4 cents per kilowatt hour. We are currently paying 6 cents per kilowatt hour, and it is increasing to 9 cents per kilowatt hour. And that is still to me, like first world problems when everybody else is
Oh, yeah.
dealing with like 25, 35, 45, 55 cents per kilowatt hour.
Yeah, which is what we are having. I was just going to mention that just for you out there to give you an idea. Germany and most parts of Northern Europe, we are in between 33 to 55 cents per kilowatt hour net. So that's tax coming on top. So that's when you have a return of invest on saving energy that is massive. But still, there's other advantages to the products too. Yeah, definitely.
Yeah. So let's talk about the products just a little bit. And the elephant in the room is your pumps are almost an order of magnitude more expensive than a lot of pumps that on paper are similar. So, and again, you could get into an entire thing about how pump specifications are kind of not well documented or enforced or anything like that. There might be some fudging there, but on paper, let's just say
Yeah.
there's a 3,000 gallon per hour pump A, a 3,000 gallon per hour pump B, and one is 10 times more than the other. So,
Happens.
so I'm like, I would say that I'm a decent power user of his products. So I know the value proposition, but I would like to hear it from you. Like, what is it that actually makes Abyzz special?
Well, if you take special to why is it pricey or more pricey than others, it is very simple. And I won't throw people under the bus with this, but in general, if you take let's say, in the Far East produced pump that is costing maybe 300 off the shelf for the end customer. We're talking about manufacturing cost material wise of $10, if at all. So this is what people sometimes don't get. Like, those products are very, very cheap in production. So the materials that are being used, I mean, there's good pumps out there. No, there's no question. I mean, my partner CoralView here in the US, they are selling massive amounts of Reef Octopus, for example, and this is one of my favorite Chinese brands, because I think they do a good job in choosing a better plastic than the real cheap ones, and they outlast, I would think, most of the other products that are like really, really cheap. But the biggest thing is just material cost. So on our pumps, we are a magnitude above that. Like, and this is why we have a very flat distribution layer. So we can't afford to have 3 or 5 stages of dealership, importers, exporters, distributions in between, because everybody would want to make their margin. Everybody has to make a margin. Like, that's what people are forgetting as well sometimes. So everybody has to live somehow, and the amount that would be added by adding those dealer stages would make the product 3 times the price, our product. So that's why we have to keep that kind of low. But yeah, it's basically all about material cost and the labor cost of the pumps. I mean, we're producing all that in Germany, in our facility, most of it, and the rest is being made by suppliers around us. But for the most part, I'd say 92% roughly of the value of products that we're using comes from Germany, and then we have some minor parts that are coming from elsewhere. I mean, there's some things you just cannot buy anywhere else. Raw material for magnets, they're always coming from China. Titanium is only available in large amounts in Russia and China. So there's not many sources to choose from right now. But yeah, all the other materials are just very expensive. But the manufacturing cost, it takes us roughly an hour to assemble the smaller pumps overall, including the driver. And the larger models, like the giant flow cannons, AFC 1200, that's a couple of hours. But that's nothing compared to the material costs that go into the pump. So it's really all about the material cost. And we chose that path to say, okay, we're just going to get the best, and we don't make any, we're not trying to make things cheaper by choosing a lesser quality. That's
Just
the only
no,
thing.
just no compromises, cost no
No
object.
compromise.
This is going to be the best product that we can possibly make.
Absolutely. And that's a rule I made for myself. If I find any way of making the product better, so delivering more customer value, let's say, I don't know, different materials for different parts of the product, that would make it better, but it would also make it more expensive, I'd still do it.
So I have a funny anecdote. We misplaced 6 screws when we took apart an AFC 150. And I'm assuming that this is not going to be covered under warranty, because that's ridiculous. That's clearly the customer screwed up, misplaced 6 screws. And so I decided to go instead to Amazon, and I priced out these small 6 grade 2 titanium. So grade 2 titanium is pure titanium.
Yeah.
Pure titanium screws. It was $100 for those 6 screws. And so
I mean, that's a ridiculous price, though. I mean,
I immediately emailed Alex. I was like, "Hey, is this covered?" And sure enough, he did send me 6 screws. So I appreciate that.
yeah,
But
no
it is
worries.
shockingly expensive if you wanted to source some of this stuff.
Yeah.
Especially like the impellers on the pumps are giant blocks of titanium.
Yeah, well, this is actually the impeller or the rotor, the inside, when you take the pump apart and you pull out the rotor, that literally is the most expensive single part of the product, of the whole pump. But it's at the same time, it is the most relevant part of the product. Like when I started designing those pumps, which was back in 2003. So that was for one customer in Germany, and he asked me to actually, can you do that? Can you build an underwater motor that would outlast anything else? And I said, yeah. In my endless naivety, I was like, sure, why not? And I said, but that's going to cost you a lot. And they said, well, we don't really care about the pricing. We just want to make sure that it performs well. So that's how it all started. And so back then, and I don't call myself a dinosaur in the industry, but I've done the hobby for, like around 30 years. So I've burned some pumps myself, from all brands basically. And one of the things that we found was the most breaking part was the rotor, because they usually were covered in plastic, and at some point they would just pop up and open up, and then you would have like all the magnet material, neodymium or whatever they were using in the water, and the pump would basically just break. And if you were unlucky, not only the rotor would break, but the whole pump motor would overheat because they weren't electronically controlled and all of this. So that was basically a wear and tear part. So every shop has these little rotors from all those brands, and you just keep exchanging them. Plus, they also tend to lose magnetic force the more often you switch them on or off.
Why
So
does that happen?
that happens because the normal motors, and we're not talking about electronically commutated motors, which means they have like a three-phase system. Like everything that is DC pump out there works with three phases, usually sine wave by now. Some are still using BLDC, block commutation, but those are all technical terms. We can get into that.
No,
But
it's perfectly fine.
all right.
My
Um,
audience will just have to catch up. It's
yeah,
fine.
all right. You can do a lot of Googling and check Wikipedia. So, but what happens is in those older style motors, and don't want to name any brands, but the ones you plug in and they go like boom and they're on. So what happens is those rotors, they have a two-pole magnet, north and south, one side. So that rotor stops when you switch it off anywhere in the pump, right? And it doesn't stop at a specific position. So now you switch it on and your AC comes in and creates that magnetic field basically on the rotor, but the rotor is not aligned in its ideal position. So the rotor has to flip, and that creates one strong magnetic burst. And whenever you give a magnet, a permanent magnet, another magnetic field that is very strong, then it will just, with time, just lose its magnetic power. Just like if you drop it, like on a regular basis. If you have a screwdriver and you want to get rid of the magnetic tip, just throw it down a couple of times, and the what are they called? The elemental magnets inside will just disalign. Magnet will be gone.
I had no idea that was a
Yeah,
thing.
yeah, definitely.
Huh. Interesting.
Yeah, so you can also do it the other way around. You can rub a screwdriver on a magnet, and it'll be magnetic then. And if you want to get rid of that, you just drop it. That's it.
Huh.
So those are the elemental magnets in there. So
Okay.
yeah. So that's like what happens, and that's why those pumps, at some point, if you lose that magnetic force, you will lose your momentum. And what happens then later, if the rotor survives and doesn't have any other damages, it basically doesn't have enough momentum to push the water around, and then it stalls. And when it stalls and you don't find out about it, then the motor will basically not run, not cool itself, but you'll still have the energy going through the windings, the stator, and then it'll heat up. And at some point, it'll just cook. And when you heat up a magnet to neodymium, I think it's more than 120 degrees roughly, they will also lose their magnetic force. So that's happening in a pump when it's just burning off. So
So the DC controlled stuff does not typically have this issue?
No, because they're all soft starting. So what pretty much every pumps ever since we developed those, I mean, back in the days when we started, there were
No DC stuff.
no adjustable pumps, and you wouldn't have wave pumps. You could switch pumps on and off,
Hmm.
and there was some. Eventually, I think it was around 2008, maybe. I'd have to talk to my friends at Tunzi, for example. I mean, they came out with some of the first controllable stream pumps back then. But usually all the pumps were just on, off. That was
Hmm.
it. And then we presented those, and I wasn't really good at marketing back then, so I didn't realize what we had started. But then at some point, there were a lot of those pumps out there. And when you run a three-phase motor, you basically have to soft start that every time from the moment when it's still, because you don't know where the magnet is that you need to drag around in your magnetic field. So that's basically what's happening, how the motor runs. You have one permanent magnet on the inside, and the stator winding creates a magnetic field that turns around. It's basically like if you would take another permanent magnet and just,
Hmm.
pull it around the motor, the inner rotor will start spinning. So you don't know that position now. So what do? You could use a sensor, which are the sensor BLDC motors. And if you want to have a really high torque, let's say for for car, electric car or electric motorcycle, those motors usually have a sensor, so the electronics actually know which position the rotor is in. But of course, sensors require additional cables, require additional magnets or optical sensors, any kind of how to find out where that rotor right now is. And so then technology became available later in the 2000s, where you could actually build the sensorless. So you would work with the so-called back EMF. So you would put a signal into your windings, and then the rotor would move, and all the windings that are currently not in use would have an induced current. So that current can be read back in your power stage, in your driver. So okay, I'm giving it this signal, so that's coming back. So I actually can find out the position of the motor. Yeah, that's how we do it basically. You feed the motor a little bit, so it starts up, moves a little bit, you read it back, and then you from there start your routine, which is leading to the next thing, programming a wave. And I recently did a video on that, explaining to people don't start from zero all the time when creating a wave, because you lose that startup time. The procedure takes some milliseconds, but if you want to be precise on your timing of the pump,
And you're talking about creating a harmonic wave.
right,
Yeah.
in the tank. So you need to be very precise about the timing, which is why you can actually adjust the pumps to a tenth of a hundredth of a second.
That was one thing that I did notice going from the non-IPU version of the pump to the IPU. And as I wanted the IPU stuff for like the better water resistance, and I think that it manages heat better because the whole thing is basically a heat sink.
Yeah.
Whereas the original ones got fairly warm, like
Yeah.
those controllers. But when you went to control the pump, like it's now like 10 times more resolution.
Yeah.
And I was like, why do you need this? And it's like, and then I was thinking, oh, to do harmonic wave, you need to do this really, really, really minute tweaking.
Absolutely. And that's when that comes into place, that startup routine. So if you're tweaking a wave and you need to adjust by, a hundredth of a second, then suddenly 5 millisecond startup time become very relevant. So what I explain people to do is that basically on the lower end, when the pump is running slow, don't stop it, run it at 1%. So that keeps the rotor spinning, just idling, and then it can speed up a lot faster because it doesn't have to do that routine in the beginning. So that's why I always say, run your pumps from, let's say, 1 to 100% if you want to do a wave, rather than from 0 to 100%. doesn't make a difference in the overall performance, but it makes a huge difference when the timing becomes relevant.
Can I ask you something about 100% power on some of these pumps? So this is an old wives' tale sort of like thing that I've always heard uh, about these controllable pumps, just controllable pumps in general, is that you should not run them from like 95 to 100%. Uh,
Why would that be?
that's for some reason like maxing out these pumps. Not your pumps. I'm
No,
talking about just, but I've heard this as like a general guideline, is that 100% on pumps is bad.
I wouldn't say so, and I think most pump manufacturers wouldn't say so either. I mean, as a general rule, if you run something with less power, you'll have less friction, you'll have less heat, so things just last longer when they're used not to the max. But um, and that's only speaking for my brand. I mean, we designed the pumps and we give you a 10-year warranty. And I don't care whether you're running them 1% or 100%, you will always have your 10-year warranty. So they're built to last however use case you're putting them in. So, and I think most other manufacturers would pretty much say the same about their products. I mean,
Is that it's okay to run it at
yeah,
100%?
absolutely.
Okay.
It, maybe not like the really, really cheap products on the market, but like all the professional manufacturers that we know, I don't know, naming a few, like, Tunzi, Spec, Arbo pumps. There's many pump manufacturers out there, Fibrock. I mean, they've been building pumps that they are noisy, but they last. I mean, these pumps, I've seen them just recently in the National Aquarium last week. Those pumps have been installed in, I don't know when, probably 87. And I mean, they're still running. They need maintenance, of course. It's a different type of design, but we're talking about pumps that move like, I don't know, 1,000 GPM. So that's different level.
Hmm.
But even these manufacturers would say, of course, you can use that product at 100%. That's what it's built for. If you reduce it, it'll most likely be better. But you got to watch that with larger pumps as well, because some pumps you actually cannot reduce down below a certain level.
Hmm.
So then they will stall. So there's also that our pumps are controllable, and most DC pumps on the market are controllable down to zero, where, for example, a pump with an asynchronous motor and a VFD, which is running, let's say, at 60 hertz in the US or 50 hertz in Europe, you can lower that, let's say, to 28 hertz maybe, and then at some point you don't have enough magnetic force, and then the same thing happens as with the fading magnets. The pump just stalls, and then you still have energy going through it, heats up, and can damage the whole motor system. So
Hmm. Interesting.
yeah,
Interesting.
so that's why they're controllable to that degree, and that's why I think, the if you're talking about quality pumps, 100% should be no problem. Like, we
Okay.
don't say it's a problem.
Good to know. Because we have definitely kind of kept with that guideline just in case. We typically don't run stuff at 100%. But
The thing though is, if if you buy a pump, no matter which one, which is adjustable, you have that big advantage of, at 100%, it'll use, let's say, A400, for example, the ones you're using, 400 watts. So if you dial them down a little bit and you're still happy with the performance, they will start dropping the energy like really fast.
mhm.
So the efficiency actually um, is kept, and when you go down with the speed, the power usage drops exponentially and
I
not
noticed that
linear.
because your display actually shows the wattage consumed at any
Right.
given power or any given setting.
Exactly.
And because I do know that like your numbering system is like an A100 is 100 watts, and A200 is
Right.
200 watts.
Exactly.
And so on some of our pumps, I'm just looking at the actual wattage consumed. It's like 20 watts.
Yeah.
And yeah, it's because on that curve, because we're backing some of these things down. So a lot of our settings are actually on like random wave and stuff like
Yeah.
that. So we do see like occasionally when the power of that pump is under 40% power, there's hardly any electricity being used.
Yes.
So
That's
that's
the
interesting.
yeah, that's a big part of that. So the like on the AFC that you're using, AFC 150, just recently had a visit to Paul Hughes at AAC in the
Hmm.
UK, and he's
Friend of the
been
show.
right. He's been playing around with that pump, and we put it in a tank, and it was running at I think it was like 40% in that thing, and it was already creating like pretty good flow in the system, and that was running at 18 watts.
Yeah.
So like yeah,
By the way,
mhm.
uh, the AFC 150 is my favorite power head I've ever used. We definitely could use more of them.
Yeah, I
They
bet
take up so much space, though.
they do. They do.
Uh,
They're not for small tanks, and you gotta hide them. But I think in a professional system, like in a raceway application, I get it. I mean, you're all about the beauty still has to be there in the system,
I
but it's
think in a 10 foot or 8 to 10 foot long tank would probably be the minimum size for something like that.
yeah,
But on a peninsula style tank, it's actually not a distracting appearance. I think that in a conventional size aquarium, it might be so where you're looking into, I guess, like one of the long ends,
yeah,
to have those things on the side might look a little bit obtrusive. But I think that on a peninsula style, where it's basically on one end where the overflow boxes are,
right.
not a big deal, and it pushes 10 feet like it's
Oh
nothing.
yeah, no, I mean this pump is built for you know larger aquariums definitely, and you need to hide it somehow. I mean, I'm using that, and my tank is 3 meters, 10 feet in length, and then roughly 3 feet, oh maybe 4 feet actually deep, and I placed that like behind the reef in the corner, and with the corals growing up, they will, just hide the whole thing. And I mean, you need to be able to hide it somehow. I wouldn't want to see pumps, even though I'm producing them, so I don't want to have them in my reef tank. But what you can also do, and this is a very interesting solution for tanks where you don't want to see the pump, you actually place it pointing up in the center of the reef. So in your systems where you have your intakes for the closed loop, you could just place an AFC blowing up. Um, that will make a massive water movement. We just presented that at the show in also a random flow pattern. You have to watch it because the water will spill on the
That
left and right.
was kind of what I was worried about. It's like, didn't I just make a fountain?
Well, no, I mean it will. You have to adjust it to in a way that it's not like looking unnatural, and you will not have a fountain in the middle. But if you have a tank that is like again a little bit larger, starting maybe at 2 feet or 3 feet in height, that is a really really cool way of creating a current because you will have water movement going like this in your tank,
Yeah.
and so you'll have all your corals moving at the same time. I think we did a video with New Wave in Germany. They have a tank that has a lot of Kaulapa in there. So, and that was moving like crazy. If you just point the pump up, it
Hmm.
creates a very nice motion.
Playing devil's advocate, isn't that kind of tricky to then hide the wire?
Yeah.
Okay.
Yeah, I mean, that's always something, I
Yeah.
know. Yeah, but battery powered doesn't work yet
No, no,
for
no.
those devices. I mean, technically that one actually could run off a battery. So, but we haven't finished the connectivity yet because we would have to build a new driver system because the driver is packed with electronics. And there's just no more space to add a 12-volt input. But the AFC is actually running on 12 volts. So you could use a car battery and have it run. So,
By the way, that is one thing that we've slowly been moving away from 120 volt electronics just because of the fact that it is in water.
Yeah,
And I think that we started to actually audit our systems by just with a multimeter, just checking for stray voltage, because any number of hundreds of devices could fail and start leaking voltage.
absolutely.
And so I think that over time we've been like transitioning more towards using 12 or 24 volt
Yeah,
DC
right.
just for like the safety aspects of it. Because like once you get above like 30 to like 50 volts in that range, it's really detrimental to your animals.
Oh yeah, not only to your animals, it could be dangerous for you potentially as well when just put a hand in
Feeling
your tank.
feeling a little tingly,
Oh yeah.
and we've definitely been shocked before, and I would and this is also again why we do these audits, because we don't use grounding probes because I think that's like a band-aid.
I wouldn't say so. So I can highly recommend using grounding
So the
probes.
reason why we don't use grounding probes is because I want to detect the problem, because like once we do our audit, we know that something is wrong, and then we will actually go fix it rather than something potentially masking the problem and having a much worse degradation of that device. So that was kind of the thought process there.
Yeah, okay. Well, I mean, there's in a hobbyist tank, yeah, or in an installation where you have those things in place, like you have people that are actually doing maintenance, checking things.
Because nobody really does that
Right.
typically.
But in your home tank, if I personally know someone who knows someone that died because of a broken glass heater
Yeah.
in his tank. So no GFCI detected it because the current actually didn't go anywhere. So
Okay.
the GFCI was still thinking it's all right because there was just, basically a short circuit in the water. So current was moving into the tank and out of the tank through the cable because it didn't leak anywhere else. So if you would have had a grounding probe, the current would have gone through the grounding probe, then flipping the GFCI basically,
Interesting.
because
Okay.
it's GFCI stands for ground fault
Current interrupt.
protection,
Yep.
right?
Hmm.
So that's it's basically just measuring how much energy goes in and how much energy, as in current, goes out. And if there's a mismatch, that's when the GFCI flips.
Hmm.
So you got to make sure that you are not the one taking the energy out of the tank or the current. Should be
Hmm.
the grounding probe. So when it comes to operating safety, I would say grounding probe is probably better
Then not.
than not having one.
Out of curiosity, was that wasn't on, I'm sorry, like 120 or 110 volt? That was like 220 or something?
What do you mean?
Because I don't know how you electrocute yourself to death on like 110 volt.
Oh well, I mean, safety regulations or the what voltage is defined is that 50 volts is able to kill you. So
Oh, okay.
so basically, the it's all about the current that can flow through your body, right?
Hmm.
And your body has a specific resistance, and the current to kill you in most cases. I mean, we're not talking about just vaporizing you, not that kind of voltage, but the voltage that actually changes your heart frequency, because that's why you're dying, right?
Hmm.
There's two ways: DC, and we're talking about real DC, meaning, I don't know, 1,000 volts DC. So if you touch that, um, doesn't affect your heart rate too much. It will give you like a short stroke, but what happens is, yeah, just you'll still fly through the room. But the problem that occurs with a DC source, and that could also be welding system, for example, it will create a very strong heat. So proteins will just clog up in your veins and arteries. So that's the real danger from DC, that this little clock will just go somewhere where you don't want to have that.
Oh, so okay, strokes.
Yes. So
Great.
then you will have like not the stroke just from the heart where just get a rhythmic
Like a heart
problem.
attack, yeah.
Yeah. But you will have the potential of having that happening and that going to your brain. So if there's I just know from Germany, but working regulation, if you have a DC surge on your body that is like with that voltage, you have to stay in hospital for at least 2 nights just to make sure that you can have immediate help in case something will be clogging up inside your body. So that's DC. And that's why I always say DC pumps are not DC pumps, but nobody knows. Well, we can cover that later. But by AC, the problem is that if the current flows, let's say from this hand to my feet or from this hand to the other hand, across my chest, basically, across um, your heart will immediately pick up that frequency or try to pick it up.
Hmm.
Our heart can't beat with 50 or 60 hertz.
No.
So it'll just start, I don't know the English word for that, but we call it flimmern. So it's basically just vibrating,
Hmm.
but it's not pumping anymore. So that's what's happening when you get a stroke, and that's when you die. So resistance-wise now, what voltage do you need to kill you? You basically just measure the resistance from one finger to the other, and then you know your body's resistance, and that's the way how to calculate how much voltage do I need to create a current that is high enough to go across my heart and actually set it off, off its normal rhythm. And a normal GFCI will be around 30 milliamps, or some in bathroom applications are as low as 6 milliamps. So that's considered a safe, like a safe value. Meaning with 30 milliamps, you have a very good chance of not dying. So everyone who has ever touched a live wire and the GFCI flipped, you don't want to do that every day. I mean, it really hurts, and it can lead to secondary issues because you break your arm or whatever, because you will be doing a good jump. I've had that once. Like, I touched something and I was sitting kneeling in front of that, and my legs just went straight. Like, I mean,
Oh, wow.
within a microsecond, and I was on the other side of the room. So that really hurt. But that's basically how they calculate. And to create in this resistance that current of 30 milliamps, you need 50 volts. So that's why 50 volts are the, that safety
Interesting.
thing.
Because we have absolutely had 50-volt water before, just based on like a couple of small hobbyist devices that are meant for like a 20-gallon aquarium.
Yeah.
It's crazy.
But then there's another thing. And I mean, this is very, very technical. But if you use a multimeter for measuring how much voltage do I have in my tank,
Hmm.
it'll give you an idea. But the multimeter has a very high impedance. So you might have 50 volts, but you would have to measure that against a resistance that is actually a bit lower. So you might have a voltage, a potential, but you don't have current. So voltage without current doesn't hurt anyone, because the current actually has to flow.
Hmm.
So you could have a stray voltage measuring of, whatever, 50 volts or 100 volts. Still, if you touch it, the current then flowing will immediately drain that potential, because you don't have any source. That usually happens with capacitive coupling. If you have a direct coupling, which would mean open wire in the tank, a lot of juice will flow through that. If you have a wire just running parallel to your tank, creating a capacity to your water body, that will create a potential, but it cannot deliver a lot of energy as in power. So
Hmm.
that actually will just drain through your body and you won't feel that. So that's why I always say just using a multimeter is not a good idea. You have to find out how much current is there. And you could do that if you would just have like a little grounding wire,
Okay.
put that into your tank, and then measure again with your multimeter. Either it's gone. If it's still there, then you might have an issue with a proper stray voltage.
Interesting. Okay. So you're converting me to the idea of using a grounding probe.
Oh yeah.
Um, so I do
we
have a follow-up question about that then. So in a system kind of like mine, that and I guess like for a hobbyist, let's say, they have a main display tank, they have a sump, and maybe they have like a frag tank or something like that, all plumbed together.
Yep.
If they have a grounding probe in one of those three containers of water, and you have a voltage leak source in one of the other ones, does that grounding probe is it still effective, or do you need grounding probes in each of those containers?
That is actually a very good question. Um, Most likely it won't be effective
Okay.
because it's all about resistance again. So, for example, if you have a freshwater tank, you have a very high resistance, so current won't flow as easy in a freshwater tank. Saltwater tanks, there is better conductivity, so yeah, the current will flow, and it will flow. Let's say if you have on your display you have a failure, the current will flow through your plumbing, through your devices, and it will flow into that grounding probe. The problem is if you're touching the tank on the top, it might be easier for the current to
Go
actually
through
go
you.
through your body
Yeah.
than go down to the grounding probe.
Right.
So that's when it could
Because
still be
in
very
some of my
dangerous.
systems, the tanks are 40 feet away to the
Right.
sump. If I have a grounding probe in my sump and my problem is 40 feet away
Yeah.
in one of my display tanks,
So
eh,
that, yeah, from my opinion, and I don't have that installed yet in my tank, so but I will be doing that. In my opinion, you should have grounding probes in every body of water, even though if they're connected with pipe work. Um, that's a lot of grounding probes. For human safety, you need to make sure that you have grounding probes that actually don't have a resistor inside. So there are grounding probes on the market, and please use a multimeter to try out whether they're actually connected, because we've had that with products that I took off the shelf in some stores just for trying it out, where you that wouldn't be conductive to the grounding pin.
oh, cute.
So it was basically just useless, right?
Ah,
And then there's some that come from that, electrostatic protection program, and they are being relabeled or reused for the aquarium market. And for getting rid of electrostatic, we're talking about very high voltages, 50,000 and up. If we all, I don't know, have plastic clothing on a plastic chair, everybody knows how that feels when you just touch your heater then suddenly, and then you get like a really, really strong electrical pulse there, and that really can like create a actual, like a spark. So to get rid of that voltage, they're using a 50 mega ohm resistor. So that will drain 50,000 volts easily, 200 volts, not so much. So that won't protect you because your resistance is actually lower than that. So you need to have a grounding probe in a system that has basically zero resistance.
hmm.
So the lower the better for human protection. So just make sure you
Interesting.
buy the right stuff when you're doing that. But that's what I'm doing. I'm putting a grounding probe in my sump, which is the body of water I'm working in for doing maintenance. But then I also do work in the tank when you're placing corals and everything. Although in the tank, my tank in that case, there's only an AFC 150, and there's going to be a second one. So they are running on 12 volts.
Hmm.
So the highest voltage you'll find on that cable will be 12 volts, and that's by law in Europe considered a safety extra low voltage. Self is that short term, and that's actually if the insulation voltage is correctly from that power supply you're using, or if it's battery powered, you could actually use that in a swimming pool and you'd be allowed in.
Okay.
Any other
Interesting.
pump is not allowed. 24 volts is not allowed.
Hmm.
So by law, if you build a swimming pond in Europe, it has to be either a pump with 12 volt or less, which is rough, getting a big pump with 12 volts, because you'll need a lot of amps to create the same power. So that doesn't really work. And that's why, by the way, the cable on the AFC 150 is a lot thicker than on our A200s and A400s, or the even bigger models. The other option would be to have in a pond, for example, a swimming pond or swimming pool, you'll have plastic non-conductive plumbing for at least 8 meters, roughly 26 feet or whatever, 24 feet, and then the pump in a separate like enclosure, so it can't, even if the pump fails or if the pump just is flooded, it is long enough of a resistance to not, damage you in the water. So it's
Interesting.
yeah.
I really was not expecting to talk this much about grounding and voltages, but that's fascinating because I did not know a lot of this.
Oh, there's endless amounts of stories. Like, just to give people an idea, that we're building 12-volt pumps. Like, the A12, AFC 150, A100, A120, and the A200 are available as low voltage pumps, which means 12 volts. So A200 is already a pretty good pump, but imagine 200 watts, 12 volts. So that's already like 10 to 12 amps going in. That's why the cable is thicker. So, and you cannot have a 20-meter cable. That's a question we get very often, because especially in larger installations, public aquariums, they have their touch pool tank right there, but then the driver is supposed to be, I don't know,
In a
next
utility
building, basically.
room far
Right.
away.
And we say we can't do that. It's, the resistance of the cable would make it so that 100 out of the 200 watts are actually just transferred to heat in the cable, and the remaining 100 watts will drive the water. So then I get a call from a wholesaler in Germany saying, but we have a 12-volt pump that is like, comes with a 20-meter cable or 10-meter cable. I'm like, nope, I don't believe you. And he says, yeah, but it says on the box it's 12 volts. I said, nope. Sure enough, he's sending me the product. We're having a good look at it. It says on the box 12 volts, transformer with it. It says on the transformer 12 volts. So usually how transformers are built is you have your primary winding going in, and then you usually have 2 windings going out. If you have 12 volts, you will do those in parallel, and then you will not exceed 12 volts. What they did, they connected it in series. So you actually had 24 volts AC coming out, and that's being rectified, and then you have like 36 volts coming out. So sure enough, at the pump, at the end of the cable, 36 volts, 12 volt on the box. So that's why they could use a 10-meter cable, 30 feet. So they had to take that off the market then, because it was really, you just can't do that, right?
No, it sounds wrong on a lot of different levels.
Yeah. So that's so far to grounding and safety. And
Yeah.
so the A400, for example, we're working on having that in 36 volts, because it is still safer, of course, just logically thinking, having a 36 volt pumping 400 watts than a full mains motor doing that.
Sure.
Performance wise, it'll be the same, but for some applications, it might just be the better option.
Like length of cable, things like that.
Yeah, length of cable, but also human safety. And we're talking about pumps that are being used in giant installations, like 1 million gallons and up. And then you have divers in the water, and then you have to switch off all the pumps, and you have to literally, like a normal switch would only would only disconnect the phase, but the neutral will still be on. And if you plug it in the other way, you could still get electric shock. So they have to make sure that all those pumps are connected to completely. That's a lot of work. Nobody does that. I've been to many aquariums where they just don't give a damn about that. And if something goes wrong, and you swim close to one of those pumps or cables or any other device. I mean, lamps falling in the water happens all
Hmm.
the time.
Or I can also imagine, because I think we had talked about a couple of applications where, like, the wildlife in those tanks damages pumps
Oh
just
yeah,
by their very,
absolutely.
they like to chew on things.
Oh yeah, I mean we've had turtles. That's why we had to develop this titanium cage for those larger pumps. Uh, we have pumps running in crocodile enclosures. They can bite things like you wouldn't
Like
imagine.
bright orange cables.
Yeah, it's yeah, they love like those things. So you have to make sure the cables are not damaged. The cable could be damaged by, you know, sharp edges on concrete or other
Yeah,
materials. So that's a big point where you have to take a closer look on how you install things and
interesting.
how you protect things against that. Yeah.
I'd like to change gears real quick.
All right.
So, um, earlier we had talked about the 10-year warranty on your products.
Yeah.
So, and previous to that, you had mentioned how trying to make a cost no object product and constantly improving on that. How do you kind of go about trying to incorporate new things into the product when your timeline is 10 years? Like, how do you justify, like, maybe in the attempt to try to improve this product, we're actually possibly making it worse
Yeah.
because our baseline is we know it's pretty good for 10 years.
Right. Yeah.
So do you like have to test things out for like years and years and years and years and years, then be like, it'll probably get us to 10 years, if not better?
Well,
How does that
yeah,
product
it's
development even go?
well, the way we do it is that we actually haven't changed anything so far. So the A400 as it is has been developed as it is mechanically. The driver has changed. In the beginning, we had those drivers with like the turning knob and
Before my time.
that long before that time. But that was the only thing that changed. So the A400 is still exactly the same product than it was 2004 when we presented it. So same rotor technology, same stator windings, still the same efficiency. Um, when we are changing things or when we are working with potentially new suppliers for materials, we do test that usually for at least 1 to 2 years under, let's say, like we don't work with, I don't know what the temperature might be in Fahrenheit, but let's say we won't have 74 for the application, but we'll put it at, I don't know, 120 Fahrenheit to make it wear faster. So we put in, I don't know, abrasive materials. Those are the things we do to make the testing even worse for
Like
the new
heavier
product.
stress testing.
Heavier stress test. And then by the time that we've been using that for at least a year in our own systems and test benches, we usually have some customers then that try out new stuff. Like when we had the A200 low voltage recently out, that had been running at multiple customers for more than a year as well before we say, okay, so now you can actually buy that. And that's how we do things. And we're actually working on something right now because we want to get rid of one part of the pump that we don't like. Uh, I can speak pretty openly about it. Like the only thing that tends to be damaged at some point or can take damage is basically the shaft. And what I don't like about it is that the fact that the customer just can't exchange it himself or herself. So that has to go back to the company or to our partners in the US, CoreView, and then they can exchange the shaft if that broke or if it wears out. I mean, the shaft, usually the wear parts tend to last between 6 to 10 years. It depends on the use case, but that's just a wear part because silicon carbide is hard, the shaft is very hard, and something has to wear at some point. Otherwise, we should, we would have to have those motors oil filled, and you wouldn't want to have that in your reef tank. So, but the bearings you can exchange yourself easily, and they don't. They are, pricier maybe than other people's bearings, but it's not an investment. So that's absolutely okay. But yeah, the shaft breaking or wearing out and not being interchangeable by the customer has been bothering me a long time. So now we've designed a new shaft and bearing system, which has now been running for more than 2 years already. But because it's such a big change, I'm not giving it out. And we just started this spring to actually send the first products to some public aquariums. So they are putting that into their tanks, and that's heavy stress test. And then we'll see, maybe in a year or so, we'll be presenting that. And that would be like the
Interesting.
first change in the mechanics of the pump in like for 20 years.
That's pretty incredible.
And every new pump we is based on that A400 design. So same materials, same shaft, same titanium, same bearings. It's all the same basically.
Yeah, because I was curious about the process that goes into that because we're always trying to do stuff better here, and occasionally that attempt for improvement leads to problems.
Of course. I mean,
Yeah.
in the end, it's literally my risk. And if I'm convinced that this will last and that I'm willing to take the risk to warranty that for 10 years, that's good. And if that doesn't work out, I'm the one having to say, okay, well, then I'll just exchange that. You go back to the old system, or, I'll just carry the cost of the warranty. I mean, that's what it is. I can't wait 10 years to present something new if it delivers a good improvement in the first place. So,
Hmm.
and if that ends up failing 5 times a year, then I didn't do a good job. Or none of my people did a good job. I mean, it's not me doing everything. So,
I
but
think that's also one of like the big selling points for us is the because kind of going back to our first talking point was just like the incredible capital cost of these devices. But I think that it makes sense for some like home hobbyists that have a tremendous amount of livestock at risk. Like
oh yeah,
sometimes people are into like either a lot of corals or they're into like very rare fish that are like literally $20,000
oh
animals.
yeah, yeah.
It's at that point a $3,000 pump is a rounding error of their budget, anyways. But for somebody like me that has so many different systems, so many devices, that I have to assume that at any given time something is breaking,
Oh yeah, that
and
happens.
that that across scale becomes crippling now. But spending the extra money to have like a peace of mind, and again, not that Abyzz can never break, but it's much less likely to break than a lot of competing
Oh yeah,
products.
yeah.
And the fact that it is more reliable across scale is an advantage that we have absolutely noticed and appreciated because we have to do less maintenance on the like the repair end. Like we do regular maintenance on the pumps and stuff. That's consistent. But
Thank you.
oh,
Most people don't.
well, we tend to be fastidious about this, but I do know that just there's just a lot of pump failures in a lot of the other devices that we use because we use a lot of hobby grade stuff, and the expectation is sometimes things do break.
Yeah, yeah,
But when you have hundreds of them, you're always going to have to be, oh, what melted down today?
yeah,
It's Wednesday. What's dead?
yeah, yeah.
Having like something that is a lot more reliable at a fundamental level is incredibly helpful for just like our day-to-day working in and around the tank.
Yeah.
So that's kind of like the big selling point for us.
So maintenance.
Maintenance. Yeah, so apparently, the failure of some of these other products might not have been the product's fault.
Yeah.
Okay.
What did you find out?
Yeah, so I found out that the conventional wisdom of what you're supposed to do to maintain pumps is just wrong and has been repeatedly been publicized wrong everywhere in the hobby for decades. Like,
Yeah.
apparently, news to me, you're not supposed to try to clean coralline buildup and calcium buildup with vinegar. You're not supposed to use citric acid. You're not supposed to use muriatic acid. You're basically not supposed to use everything that's recommended.
Oh, I mean, yeah, you can use that, but it depends on what you're cleaning.
Yeah,
You
and
know that.
apparently we have broken many a thing
Yeah,
doing such.
that's the thing that is not well known. So, I mean, there's a bunch of people out there that know that. Chemists, hobby chemists, yeah, but other pump manufacturers, so they know. But the problem is that we as a manufacturer, we clean pumps on a daily basis. Like we have a service department in Germany, Core Review has a service department. So a lot of people are literally sending in pumps, not only because they're broken, but very often because they get new bearings and they just don't want to do that themselves. Sometimes we get pumps in that are being sold used. And then the people are asking, oh, can we transfer the warranty? And we say, yeah, we would do that, but only if you send the pump to us prior to do that, so we can actually check whether the pump is in a good condition. Uh, so you're not getting ripped off buying a used product that is actually, problematic or has been dropped or whatever. So we get those pumps in, and we had to find a proper cleaner to use because we get pumps in you wouldn't believe. Like nowhere as clean as your systems here are. I mean, really bad. And we have pumps running in the open ocean and in many areas of the world. So that starts in northern Germany in little harbors or way boat houses to keep detritus out or just stuff that floats in. So that's where pumps are running. So they're completely encrusted and covered in mussels, for example. We've on Maldives we have pumps sitting on the reef delivering water to those coral facilities there. So these pumps tend to look very disgusting and they need to be cleaned at some point. So we get those in and then they usually go for a bath overnight. So we put them into our acid basin, which we actually heat up. So we have that running at 33 degrees Celsius, so around 80 Fahrenheit, I would say.
80, 90 degrees
Yeah.
Fahrenheit.
So so that's why we put the pump in, and then we actually move the water around a little bit. So there's a flow pump in that tank. So all of that stuff is going off, and if the pump is still operational, we also switch it on and let the inside clean throughoutly. And then the next day they are rinsed off, and then people can actually start working on it without, having that funny smell coming out of the pump. Because when the pump has been in a package for 3 days,
It's probably smelling ripe.
it's not nice, really not nice. So yeah, and so we had to find a cleaner to work with our materials. And again, another point, we are very open about what we use and what problems you could have, because actually on the manual, which you can download on the website, there's a list of materials. All the materials on the Abyzz pumps that are actually in contact with the medium that's being pumped are listed. So if you would want to try out something, or if you would want to start pumping gasoline, you can actually go in there and test all the materials or read up on those materials, whether they would withstand that. So, so going back to that, we chose a specific acid. And because we live in Germany and Europe, there are regulations. We can't just sell something named magic powder and then not write on it what it is. So, I mean, there's no secret. I just don't know how to translate that
I
kind
think
of
it is
acid.
sulfamic acid.
Could be. Really have to look that up. It's amidosulfonsäure.
Yeah. So it's a amidosulfonic acid or sulfamic
Okay.
acid in English.
Yeah, so that's what we use. Feel free to buy, like in big chunks. But
And also the reason why I do want to mention it like by name is that sometimes Coral View is sold out of Abyzz magic powder.
yeah, that's true. Yeah, that's true. And I mean, we are still working on making it better and the packaging better, and maybe smaller packages that are maybe cheaper for people that just have a tiny pump. Because usually one of those packs, if you have like a 2-gallon bucket and you put that in, you could actually clean probably 8 pumps with one of those packages. But we're working on the color indication system on that, so
Oh, that's nice.
that'll be something new. So it'll actually show when it's depleted.
Oh, it's perfect for us.
So that would be something. But yeah, so we've chosen this acid for a reason, because we've tested our materials in that. And then, but there's always people smarter than we are and smarter than anybody else. So they go like, oh yeah, we just use citric acid, or we just use, I don't know, vinegar, as you mentioned, all those different types of acid. Or some people just put in bleach, like 10% bleach. We've had that.
Okay.
And that is the worst.
It sounds aggressive.
Oh yeah. And let's say citric acid, that's a household thing. Everybody can buy that. And it works well on, let's say, the rotor. And it works well on the ABS we're using. It doesn't work so well on PA, polyamide, and also not on some certain types of rubber, which we are using for the O-rings that are holding the bearings in place. So, and then there's also impeller wheels, AFC 150, for example. Perfectly fine with what we are using for cleaning and what we are selling for cleaning it and recommending. If you put that in vinegar or some other acids, it'll just dissolve, basically.
We noticed that on one of our things, like, okay, what's going on here? And because we do have
I think there's a picture of that too. Like I got a picture.
Yeah.
I don't know whether it was from your staff or from the other customer that had the same issue, because they hadn't been trained or educated on that. So they were using, I think, vinegar as well.
I think we
or concentrated
that might have gotten
vinegar.
soaked in muriatic acid.
Yeah.
So, because here's the thing, like, especially when you start to talk about organizations, it was news to me, actually, that my staff was using some of these things specifically on pumps.
Okay.
Because I, for a while now, kind of knew some of this to not use. And I assumed that the pumps were getting cleaned in the pump cleaner,
Okay.
not
Yeah.
on this other thing that we were using, typically to clean some acrylic trays. Because I don't care. I mean,
Yeah. Right.
that's great for that. It
Nothing will
works
happen.
way
Yeah.
faster and whatever else. But I was like, are you guys cleaning the pumps in that? Because that would explain a lot.
Yeah. Yeah.
And sure enough, it's like, yeah, it was kind of, just coming apart. And so we have one AFC 150 that's a little weaker than the others.
Okay. Because it's lacking a little bit of
Yeah, a little bit of
impeller
material's
diameter.
gone.
Yeah, yeah. And then if it's lacking too much of that, it will say it's running dry, because there won't be any more momentum on the shaft. Yeah. Yeah, so that's important. So I can highly recommend, as I mentioned earlier, if you out there are using equipment from other manufacturers, talk to the manufacturers, read the manual, and use the product that they are recommending for cleaning or working with their product.
Yeah, and also just because people are not materials experts, but saying something is plastic could mean a universe of possibilities.
Oh, absolutely. Absolutely. There's many, many different varieties. And, there's stainless steel is not stainless steel. And there's like, I don't know,
Titanium's not
100
titanium.
grades in between.
Yeah.
And also qualities. I mean, you could buy the same grade, but a different quality. And then it might not be that great, even though it was labeled that great. So and stainless steel is one of my favorites.
Yeah.
I've learned from a good friend, actually from Titan Aquatic Exhibits. You might know those. Neil told me, well, no, Brian, say it slow, stain less.
Mhm.
it doesn't say it doesn't stain, right?
It
So
definitely will rust.
it will rust, and I've seen that on plenty of equipment and installations where you end up spending a lot of money and investing a lot of money in filtration systems and anything, and you're trying to make it look good, and 3 years later you have like rust running down
Mhm.
everywhere, and you can't scrub that off. It's it goes into every material and just doesn't look good anymore then.
One other topic that
All
I wanted
right.
to cover with you. Because I remember when we were visiting the Netherlands together, we had a spicy little chat about the use of closed loops at all.
Oh yeah. Yeah, that's
And
true. Yeah.
so here at Tidal Gardens, we like us some closed loops. And the reason why I like to use closed loops here is because a lot of our systems are very long, 10 feet plus, and they are peninsula style. And oftentimes, to reach that far end of that peninsula, it becomes a challenge. And so sometimes people have to like put power heads on that decorative peninsula nose.
Yeah.
It's very unsightly. And it's also difficult to source pumps strong. And obviously, AFC 150s will do it.
Yeah.
A few other pumps will as well. But to have a power head on the overflow side that can hit all the way 10 feet away plus, uncommon. So oftentimes, like the closed loop implementation has been really good for us. And it also is nice in the sense that you can hide that with aquascaping if you'd like. And you can also then service the pumps fairly easily and dry.
Yeah.
So those are all like the big selling points
If you
for
plumb
me.
them in correctly, and if you have valves in place, and
Yes.
if there's not 50 gallon of water returning,
Right. And we
like,
we actually have drip trays. So
yes, I
when we
saw
open
that.
it up,
Yeah,
we vacuum it right there and it
perfect.
stays dry-ish.
Oh
But
yeah.
there are complications. It is not just like, oh, buy this pump and you have yourself a closed loop. No, you have your closed loop after about another $1,000 in plumbing
Oh yeah. Well,
because
yeah,
you can go pretty crazy.
yeah, you can. And I mean, you need good valves.
Hmm.
I highly recommend that as well. Like,
Hmm.
people tend to go cheap on valves. They get them. I don't know where they're sourcing those, but again, I'm very active in that professional side of the business with aquaculture, public aquariums. We go to these conferences and symposiums for a reason, like also and raw, um, to also learn about all the other manufacturers that are out there, all the vendors that deliver quality products you'll find on those shows. And there are so many differences just in a ball valve. You wouldn't believe that how just by material, design, everything, like noise, there's so many things. And getting spare parts so you can redo them with new seals and everything. So, and I've seen so many hobby aquariums, and I've built my own, and I bought cheap valves, and then at some point, like 3 years in, you see that little salt crust on that valve, and
And
it's
sometimes
just
they stop turning.
absolutely, yeah.
Yeah, just for future reference, guys, if you want to build a serious business system that's going to last a long time, the valves at Home Depot and Lowe's, it's probably not something you want.
I guess not,
There
no.
are there are much better versions of that for sometimes not that much more, sometimes a heck of a lot more.
Oh yeah,
So, for
yeah,
example, a Spears gate valve
yeah,
is hundreds of dollars.
yeah.
Are they that much better? Meaningfully so, kinda. There's a lot of really good brands out there. Like
Oh yeah.
Asahi makes very, very good.
Asahi, I know the
Probably
people from Asahi very good from all these conferences.
Japanese.
GF is
Yeah.
is one of the big names as well. So there are some, yeah, get quality stuff that you can actually
Yeah.
interchange. Another super important thing, in my opinion, the threads on many of those are completely different.
All of them are completely
And
different. Yeah.
sometimes you buy a valve, and then 2 years later the valve breaks, or you can't turn it anymore, or you don't get spare parts. So you want to put a new one in, and you're trying to buy the same valve. It looks exactly the same, but the threads won't match.
Hmm.
And then you have to cut everything out and redo all the plumbing?
So we started to do now is to have threaded valves. So not even true union, because
Okay.
unless you need to have a true union, and there are reasons to have true unions, okay?
Mhm.
But if you don't really need to have a true union, well, I guess you could always just do it because some of the true unions have their own standard threading
Yeah,
for pipe work. Um, Use that because now you can just swap out that entire thing. You don't have to worry about just like swapping out just the valve portion.
exactly. Yeah.
So don't glue that sucker in there.
Yeah. Also a
Thread it in there.
possibility. But
Yeah.
if you go for manufacturers like GF or Asahi or Spears or whatever, you can always call those people and say, I have this valve. Can you send me exactly that part that will fit in there? And you'll be able to just exchange that part.
Okay.
I mean,
Yeah,
all the,
that's interesting.
oh,
I've never successfully done that. We have a lot of true union ball valves here.
okay.
I've never successfully
Oh,
replaced the interior part.
I mean, we don't have, I don't actually know whether we have Asahi in Germany, but with GF, no problem at all. Like you will get those spare parts, and they have everything for every valve, and they
Interesting.
all have a number on them, so you can identify them. So yeah, that's good stuff. But that's important. Like don't save on those components, especially not in a hobby where you end up spending so much more money. I mean, just food, right? I mean, if you have a lot of fish, you'll need a lot of food. So, and then that's a 20-year thing, and you'll spend so much more on food than on your valves or on your initial installation. Makes no sense to go cheap on those components.
And nice plumbing is kind of nice,
Absolutely.
especially if you're actually turning the valves, and you're supposed to turn the valves, you guys.
Yeah, yeah. Every now and then you should do that.
Yeah.
Yeah.
But okay, going back to the closed loop specifically though,
Oh yeah.
what I'm going to go ahead and just assume you don't like closed loops.
Actually, I do. In general, um, I wouldn't do them again on my home reef tank,
Okay, why?
because I've had leaks. And as soon as you drill a hole into a tank, there is a risk that will leak, and the risk is just higher than without the hole. So, I mean, given that the tank doesn't come apart in general, but and then you have those unions, you have valves underneath it, and if some people just don't glue properly or they use cheap stuff, and then that starts leaking, and that has a potential catastrophic failure thing going on. Like in your living room, you don't want to have 1,000 gallons of water when you have nice wooden floor or whatever. So that I always see that risk. Um, and
Because
I
it is possible to just design around this and not have that risk potential. No, meaning
yeah,
don't have a closed loop, right?
yeah,
Just if you can avoid a catastrophic failure, you probably should.
yeah. I mean, there's also the option that you could use in a closed loop, that you have like a separate overflow chamber with like a even reduced height, but it would make sure that the intake of the overflow of the closed loop wouldn't be able to empty the tank completely. So that helps as well. I've
Hmm.
seen that on some installations, or just the pipes standing into the tank in larger systems. So that works. I mean, there's always a way to, but think about it, like analyze your system, think of what what if. That's always the question. Like, what if power failure? What if something clogs up and it's just closed? So will the tank overflow? Will this happen? So I always think systems through like that. I sit down with my staff, we build something, and then we go like, okay, so anyone has any idea what could happen? And then you sort out, you write down all the things that could happen, and then you check against those things. Like, is it safe to do so, or do we have to change that? And for my personal experience, am using a flow pump in my tank, AFC, and no holes in the bottom except for the overflow box. So that's my approach to that. But I also have customers, and one of the big ones in Saudi Arabia now, giant project, 400 raceways, pretty much the size of your tanks, all closed loop, like on each of them, because they didn't want to have anything sticking out on the inside of the tank, so they can easily clean it out. Like there's no corners and edges, and they also wanted to be able to exchange the pumps dry. So there's reasons for that. But they also have floor drains in the whole building. So there's, for them, it's not a catastrophic failure if they lose. If we're
One
talking
raceway out
Right.
of 400, it's like
Exactly.
tragic loss.
Yes,
But we'll be back up
exactly.
right in
So-
about 4 hours.
You always have to probe those things against what's your specific
Yeah.
appliance, or which kind of animals are you. I mean, you will, if you have the last coral of this kind, you should maybe take some more precautions than if that's an animal or anything that you're trying to keep alive that's available everywhere and that's super easy to keep. But I've been to systems where they're literally trying to save the last corals. I mean, in Florida, there's a big thing going on. And on many systems that are trying to save those, I mean, there's many, many good people do a great job. But I've seen some systems where they just have one pump and then there's no monitoring on that. And I said, well, what if the pump just turns off? How often do you go into this room until you find out that, what's the time interval? Those are things you need to think through if you have your system running.
Yeah, for sure.
Having a spare, it's always a good idea. That's
We need to get a spare AFC 400 badly. But I guess we do have a workaround. In a pinch, I will steal one off of a protein skimmer, and it'll screw right into the other housing, and we're back up and running. In a pinch. I don't
Absolutely.
need that skimmer running for a little
absolutely.
while.
And anyone who's seen my video on my little sump room and whether it's too big or not, I have 2 return pumps for a reason.
Mm-hmm.
Exactly that. So if anything happens, and I know how it is, like even though I run a pump company, if I need one, there's none available because they're all sold or they're all gone or they're in production. So I had to make sure that I can actually have a catastrophic failure of a pump, but not have a catastrophic failure of the system.
So you have 2 returns.
I have 2 return pumps separately, individually plumbed, so it's also 2
Yeah.
lines going back and forth.
That was
So I don't need check
wanted to do
valves.
that. So I wanted to do that, but you see how some of my stuff is implemented. It's miles extra
Oh,
of,
yeah,
of
absolutely.
piping
Yeah.
just to add in another return.
Yes.
But I
But-
would love to have done that.
Yeah, but that was my basically way of I have I think there's 6 A200s running on my system, and they're all the same, and they all have the same connectors. So I basically used a union on the intake and on the what do you call that, the
Output.
output, yeah. So, and they're all the same size, all the same threads, all the same brand on all those pumps. So what I can do at any given time is I just switch off one of the return pumps, take it out. The system will still be fine with half the turnover. And I could also dial up the remaining pump to reach the same level. And our new ACS system, the Abyzz control system for the IPU drivers, will be actually able to do that automatically. Like one pump fails, the other one will pick up the slack.
Interesting.
So that system will be available shortly. But yeah, I can use that pump, unscrew it from where it is, and I can just replace any other pump on the system with that pump. So I always have a hot spare, which is great because if you have a cold spare on the shelf, usually what ends up happening in places like public aquariums or shops or anything is that, oh, we really needed this one screw. And by the time you need the cold spare from the shelf, you'll open up the box and you'll find that screw missing. And then you can't use that
Oh,
cold
that's
spare.
horrifying.
So we've had that plenty of times because
You just
then,
use it for parts.
yeah, we
Oh
used
my
it for
gosh.
parts. That happens. So having a running spare, you can be, absolutely 100% sure
Built-in redundancy
it'll be
right
running.
then. Yeah.
So yeah, that's my approach to that. But
Interesting.
yeah,
All right, you guys, that pretty much does it for our conversation with Alex. Thank you again so much for joining us.
Thanks for having me.
I've learned a ton from this conversation, so
All right.
I
I hope it helps, and I hope it helps other people
exactly.
too. And
Yeah, I hope you guys
if
got
there's
something out of it.
questions, please put it in the comments, and we do another talk on the next time we meet.
Absolutely. Take care, you guys. Appreciate it.
Thank you so much for watching. Take care. Bye bye.